What if one of the best places to find life in our entire solar system is not Mars, not the moon, but a small, icy moon orbiting Jupiter over 600 million kilometers from Earth? That moon is called Europa. And right now, in 2026, scientists are in the middle of one of the most exciting debates in the history of space exploration. Is there life hiding beneath Europa's ice? Back in 1610, Galileo Galilei spotted 4 tiny points of light orbiting Jupiter through his telescope. Europa was one of them. For the next 300 years, it was just another dot in the sky. That changed in the 1970s when NASA's Voyager spacecraft gave us our first close-up looks. Europa's surface was incredibly smooth, covered in a web of cracks and lines with almost no craters. Every other icy body in the solar system is riddled with them. But Europa looked young, almost fresh. The real game changer came in 1995 when NASA's Galileo spacecraft arrived at Jupiter. Up close, Europa's surface looked like a giant jigsaw puzzle. Massive slabs of ice had shifted, cracked, and refrozen over and over. Some of them looked like they had floated on top of something. Galileo's magnetometer picked up something even more incredible. Jupiter's magnetic field triggered a secondary magnetic field on Europa, and there is really only one explanation for that. There has to be a layer of electrically conductive material near the surface. The most logical candidate is liquid salt water. Beneath Europa's icy crust, there is an ocean, not a pond, not a lake. A global ocean of liquid salt water stretching potentially up to 100 kilometers deep. Europa holds more water than every single ocean on Earth combined. And where there is water, scientists start asking a very dangerous question. For decades, scientists believed life needed sunlight. That was the golden rule. So, when searching for life beyond Earth, they focused on places in the habitable zone, close enough to the sun for liquid water on the surface. Mars became the #1 target. Then, scientists found something that rewrote the rules entirely. Deep in Earth's oceans, in places where no sunlight has ever reached, they discovered thriving ecosystems clustered around hydrothermal vents. Life was thriving there on heat and chemical energy from the Earth itself. No sunlight needed. Europa suddenly became one of the most exciting places in the solar system. But here is where things get complicated. In January 2026, a study published in Nature Communications threw a massive wrench into the Europa life story, led by Paul Byrne at Washington University in St. Louis. The team modeled Europa's interior and the gravitational forces Jupiter exerts on the moon. Their conclusion was not what the optimists were hoping for. Europa's seafloor is likely geologically quiet, no active volcanoes. Most importantly, probably no hydrothermal vents. Europa's ice shell is between 15 and 25 kilometers thick. That is 4 times the height of Mount Everest, just in ice. Beneath that sits an ocean, and beneath that, a rocky core that has been cooling for billions of years. Jupiter's gravity does squeeze Europa through a process called tidal heating, and that is actually why the ocean stays liquid. The Burns team found that this tidal heating is not strong enough to drive geological activity on the seafloor. So, if there are no hydrothermal vents, where does the energy for life come from? A researcher named Kevin Trung has a fascinating answer. He proposed that life on Europa might not need hydrothermal vents at all. The energy could come from radioactive decay in the rocks themselves. Europa's rocky core contains naturally radioactive minerals. Elements like potassium-40 slowly decay and release energy over time. If those radioactive elements are leaching into the ocean, they could release a steady trickle of energy throughout the water. Not a lot, but potentially enough to sustain simple microbial life. And unlike hydrothermal vents, that energy could be available anywhere in the ocean, not just at the seafloor. There is another piece to this puzzle. Scientists have long wondered how nutrients from Europa's surface could reach the ocean below. Jupiter's radiation constantly hits the surface ice and creates useful nutrients. But how do they get past kilometers of ice? In January 2026, K-team at Washington State University published a study proposing that dense, nutrient-rich ice on the surface could separate and sink downward through the ice shell, delivering those nutrients directly into the ocean. Their modeling showed this process could work consistently, creating an ongoing cycle of feeding the ocean from above. And then there are the plumes. In 2013, the Hubble Space Telescope captured what appeared to be geysers of water vapor shooting up from Europa's surface. If those plumes are real, material from Europa's ocean is being vented directly into space. A spacecraft could fly through them and sample that ocean water without ever landing or drilling. Scientists re-examined data from Galileo's 1997 flyby and found signatures consistent with the spacecraft having flown through one of these plumes without knowing it. The Juno spacecraft has also detected potassium in Europa's atmosphere. It's an element that ties directly back to Strong's radioactive decay hypothesis. All of these clues are pointing in the same direction. Okay? And that brings us to the most exciting part of this story. NASA's Europa Clipper. Europa Clipper is the largest spacecraft NASA has ever built for a planetary mission. It spans over 30 meters, tip to tip. It launched in October 2024 and is currently hurtling through space toward Jupiter, where it will arrive in April 2030. It will not orbit Europa directly. Jupiter's radiation is brutal enough to destroy unshielded electronics in days. Instead, Europa Clipper will orbit Jupiter and make nearly 50 rapid flybys past Europa, dipping as close as 25 kilometers above the surface. On board, it carries 9 science instruments, ice-penetrating radar that will build a 3D picture of what lies beneath the surface, a magnetometer to confirm the ocean and measure its depth and salinity, cameras for high-resolution mapping, a thermal imager to find warmer regions where liquid water could be close to the surface, and a mass spectrometer to analyze the atmosphere and, if those plumes are real, sample material directly from the ocean. Europa Clipper is not a life detection mission. What it is designed to do is answer 3 fundamental questions. Does Europa have liquid water? Does it have the right chemistry? Does it have an energy source? The answer to all 3 is yes. It sets the stage for a future mission that could actually search for life. Scientists are already working on that future mission. One concept is an ice-penetrating probe that would melt through the ice shell using nuclear power and deploy a small submarine into the ocean below. Prototypes are being tested right now under the Antarctic ice shelf here on Earth. If Europa's ocean turns out to be habitable, it completely rewrites where life can exist in the universe. Europa is over 5 times farther from the Sun than Earth. If life exists there, you don't need to be in a habitable zone at all. You just need water, energy, and the right chemistry. And those ingredients could exist almost anywhere. That changes everything. Ocean worlds like Europa can harbor life, and there are many of them in our solar system alone. The universe might be teeming with life. We just haven't found it yet. So, where does this leave us in early 2026? We are in a fascinating and contradictory moment. One study says Europa's seafloor is too quiet for life. But brand new ideas around radioactive energy, nutrient delivery from above, and ocean plumes are opening up entirely new pathways. The truth is, we do not have enough data yet, and that is exactly why Europa Clipper exists. When it begins its flybys in 2031, it is going to answer questions that have been hanging over this moon for decades. Are we alone? Europa might have the answer, and in the next decade, we might finally be close enough to hear it. Hi everyone, Mark here. If you are fascinated by the engineering of the future, subscribe and follow for more science, natural, and cosmic content.